This video demonstrates how to conduct the design optimization study using ANSYS Workbench. The example considered over here is a rectangular plate with the hole at the center. The dimensions of the plate are: the length is 100 mm, the width is 50 mm, the diameter of the central hole is 25 mm. The plate is constrained in the left vertical edge in all directions. The right vertical edge is applied with a force of magnitude 100 newtons. In the x direction, positive. The objective of the analysis is to evaluate the stresses generated in the plate due to the application of the load. The variable parameter in this analysis is the thickness of the plate, which means the thickness of the plate is varied from 2 mm to 0.5 mm in its thickness, and the stresses are recorded. The analysis was conducted for only one thickness of the plate. The remaining thicknesses were automated by the ANSYS and the results were captured. The left side graph demonstrates the graph. It dictates the values of the stress with respect to the thickness. The vertical axis talks about the stresses generated in the plate. The horizontal axis talks about the thickness of the plate. Thickness ranging from 2 mm to 0.5 mm with a step decrement of 0.5 mm. The mesh which is generated on the plate is done with a special technique to achieve this systematic pattern of the elements. This is also called as structured mesh or mapped mesh. We will study how to automate the process to record the stress values for the different wall thicknesses without involvement of much manual work. Let us begin with the tutorial. The CAD modeling software used for this analysis is Parametric. We'll create a model of the plate with a central hole. Pick on the fill. Before that, let us define some of the parameters which are required for the dimensions of the plate. Pick on tools. Pick on the parameters. The parameters window is now open. Let us add the parameter by pressing on the button over here. Enter the name of the parameter as GRS _L. The length of the plate to be defined as 100 mm. Enter. Click on this icon again to add the next parameter. Enter it as GRS _W. This defines the width of the plate. Define the next parameter with the name GRS _thickness. Let us enter this parameter as 5 mm. Once the parameters are defined, pick on OK. Pick on the model on the left top corner. Select the Fill option. Pick on the Preferences. Select here Define. Select the sketching plane. In this case, let us make use of the front plane. Pick on the sketch. Select the sketch view to reorient the sketching plane. Draw the rectangle starting from this corner to the right bottom corner. Draw the center line, vertical and horizontal. Use the constraints, symmetry. Select the top vertex and the bottom vertex to be symmetry about the horizontal center line. Similarly, about the vertical axis, left and right vertices need to be made symmetric. Press middle mouse button to deactivate the constraint. Double-click on the length, enter it as 100 mm. The height of the plate to be 50 mm. Draw the circle at the center of the plate. Diameter of the plate to be 25 mm. Pick on Done. This defines a 2D planar surface for the plate. Let us don't bother about the thickness at this moment, because anyhow we will be defining the thickness for this plate in ANSYS. The plate is not parameterized because we have not entered the parameters for the dimensions. Therefore, pick on the fill, right-click, pick on Edit Definition, pick on the Preferences, say here Edit, pick on the Sketch View, double-click on this, enter the keyword GRS _ L, enter. It says, do you want to add this relation? Yes. Similarly, GRS _ W, enter. Pick on Yes. Pick on the Done, which means the dimensions of the plate are now parameterized. Let us split the surface into segments for ease of meshing. Pick on the datum plane. Select this vertex. Press hold Ctrl. Select the other vertex. This will define one plane passing through these two vertices. Press hold Ctrl and select the surface. This is going to define a plane which is passing through these two vertices and perpendicular to the surface. Pick on OK. Similarly, select the datum plane option. Pick on this vertex, press hold Ctrl, pick on this vertex. Press hold Ctrl, select the surface. This will define one more plane. Pick on OK. Let us split the surfaces now. Select the quilt from the selection filter. Select the surface over here. Pick on Trim. Select the datum plane. We need to keep both the surfaces after the split. Hence, adjust the option over here to keep both sides of the surfaces. Pick on Done. Now, pick on the other surfaces. Pick on the trim over here. Select the respective plane and keep both the sides. Similarly, pick on the surface, pick on the trim, select the same datum plane to split surfaces. Now pick on this particular surface, pick on trim, select the datum plane and keep both sides. The same way, the other surface need to be trimmed with this datum plane. Keep both sides. Pick on, done. The body is single but is been split into multiple surfaces. This splitting of the surfaces is to facilitate the ease of the mesh generation. Pick on, save. File, save here. It will be saved in a folder called as ANSYS Optimization Study, and the name of the file is plate with a hole PRT. Pick on, OK. Pick on the tools. Under Tools, select the option again as Tools. Select on the ANSYS 14, say here ANSYS Workbench. This is going to relate this CAD model to the ANSYS. Pick on OK for this window. We can observe the geometry was being imported into the project schematic automatically. Let us proceed with the structural analysis. Pick on the geometry, right-click on the geometry, and pick on Edit Geometry. Ensure the unit system for the ANSYS Workbench as millimeter. Pick on OK over here. Pick on the Attach over here. Drag the details of the window. Enter the parameters as yes and parameter key to be GRS. Remember, in the Creo parametric, we have entered the parameters with the name GRS underscore L underscore W underscore thickness. Those parameters will be linked to ANSYS when we enter this keyword. Pick on Generate. We can find that the surface was being imported. It can be seen from the details of this particular import. 3 parameters GRS underscore L, GRS underscore W, GRS underscore thickness were imported. Select all the parameters, which means parameterize all these parameters by picking on this particular space. We can observe P, which represents these 3 parameters, are now linked from Creo to ANSYS. Pick on the part body here. We can find all the surfaces are clubbed together to form a single part called as plate with hole. Expand this plate with hole. We can find 6 different surface bodies. Now we need to unite all the surfaces to make it as one body. Select here. Tools, pick on the Connect. Select the first edge, press hold Ctrl, select the other edge, pick on Apply, select here Generate. Similarly, pick on the first edge, pick on the second edge, pick on the tools, select here Connect, pick on Apply, Generate. Similarly, select the first edge, select the second edge, pick on the tools, again Connect, pick on Apply, select here Generate. Select the first edge, press hold Ctrl, select the second edge, pick on Tools, select here Connect, pick on Apply, select here Generate. Similarly, select this edge, press hold Ctrl, select the other edge, pick on Tools, select Connect, pick on Apply, and say here Generate. We can find that all the 6 surfaces which got split were now combined to form a single surface. This is very important for generation of the structured mesh. Pick on Save here. It will ask for the directory to save. Let us enter the name as ANSYS Optimization Study. Enter. Now, pick on the static structural analysis. Drag the static structural on the geometry. We can find a new static structural file is created. Pick on the model, right-click, press hold, pick on Edit. This opens the mechanical window. Pick on the View, select here Windows, Reset Layout. The window will be reset. Pick on the graphics. This will show the body. Under the geometry, pick on the plate with the hole. The thickness of the plate is not yet defined. Select the thickness and enter it as 2 mm initially. And make this thickness to be parametric by picking on the box just beside the thickness. We can find the P symbol, which is parametric. Pick on the mesh over here, right-click, Insert, pick on Sizing. Under Geometry Selection, make sure that the surface is selected in the selection filter. Right-click, pick on Select All. Pick on Apply to confirm the selection of all the surfaces. Face sizing need to be given as the element size of 3 mm. Enter. Right-click on the mesh, pick on Generate Mesh. This will create a mesh which is not a structured mesh. Right-click on the mesh, Insert, pick on the Mapped Face Meshing. Very important. Under the Mapped Face Meshing, right-click and pick on Select All to select all the surfaces. Make sure under the selection filter, the face is selected. Pick on Apply. Right-click on the mesh, pick on Generate Mesh. This will give us a mesh which is a structured mesh. We can observe the thickness was taken by ANSYS automatically. Pick on the file, save here. Let us apply the boundary conditions. Right-click on the static structural, Insert, pick on the fixed support. Ensure that the edge is selected in the selection filter. Pick on the left side edge. Pick on Apply. Right-click on the static structural. Pick on the Insert. Select here Force. Select the right edge of the plate. Pick on Apply. The force need to be defined with a magnitude of 100 Newton with respect to the components. That is, X direction need to be applied with a 100 Newton force. This can be observed from here. Right-click, pick on the view, set the orientation to be front view. Right-click on the solution, insert, pick on the stress, pick on the equivalent or von Mises stress. Right-click on the solution, pick on Solve the problem. Here, we are evaluating the stress for the plate. That's the reason under the results, only stress was been included. There was a problem in stitching the surfaces. Let us visit back to the design modeler. Pick on this particular edge. Pick on the tools, select here Connect. Pick on this edge, press hold Control, select the other edge, pick on Apply, select here Generate. This step we have missed earlier. Pick on Save. Now come back to the mechanical window. Right-click on the geometry, right-click, refresh geometry. The geometry gets updated from the design modeler. Right-click on the mesh, pick on Generate Mesh. We can observe the mesh is now updated. The fixed support and the force are not changed. Right-click on the solution, pick on Solve. Pick on the equivalent stress. We can observe the stress is generated at the whole regions. We need to parameterize the maximum stress which was generated. Hence, scroll down in the details of the equivalent stress. We can find here the minimum and the maximum stress which was observed over the time. Pick on the maximum box and make it parameterized. Very carefully do this step. Pick on the file, select here Save Project. Visit back to the project page. We can observe that there is a loop which has been formed. Right-click on the parameter set. Pick on Edit over here. The dimensions which were being parameterized are recorded over here along with the stress. GRS length, GRS width, GRS thickness are included, and the thickness of the plate which we have specified as 2 mm was also recorded, and the equivalent stress which was also parameterized. We want to make the thickness of the plate to be variable. That's the reason. Pick on the current design point. Right-click, pick on Duplicate Design Point. Similarly, right-click, Duplicate Design Point. Right-click, pick on Duplicate Design Point. In all three design points, change the value to 1.5, 1 and 0.5, which means the thickness of the plate has been varied now, but the stresses are not yet evaluated. To evaluate the stresses for all these thicknesses, pick on Update all design points. Update all design points. Some open editors may close during this process. Pick on OK. We can find that it is updating the models and the components in the static structural for design point 1. This updating process for all the design points will take few minutes of time. The solution process depends upon the complexity of the problem. Now we are at the design point 3. We can see the message over here. It has been ready, which means all the design points have been evaluated. We can find the equivalent stress. Maximum was 4 mm for thickness of 2, 5.5 for thickness 1.5, 8.2 for thickness of 1, and 16 for thickness of 0.5. Let us plot the graph of the stress with respect to thickness. Pick on the start, pick on the Excel sheet. Maximize the window. Name this column as thickness. Name the other column as von Mises stress. Copy the thickness of the plate. Paste it in the thickness. Copy the stresses and paste in the von Mises stress column. Pick on the insert. Select here the line chart. Select the first 2D line chart. Right click on this. Pick on Select Data. Horizontal axis and the vertical axis can be defined from here. Pick on Add. Enter the name of this as stress. Enter the series value as the stress values. Pick on OK over here. Similarly, under horizontal axis, pick on Edit. Under the axis label range, select this button and select all these values. Pick on OK over here. Pick on OK. We can find that we have plotted the graph for the stresses with respect to the thickness. Right click on this. Pick on Select Data. Pick on the stress here and pick on Edit. Enter the name as thickness versus stress. Pick on OK. Select here OK. Now browse for modifying the table or the chart. The legend should be shown at the top. Now we can find here the legend is shown at the top. Under the axis titles, the primary horizontal axis title need to be below the axis. Enter it as thickness. The unit is millimeter. Similarly, pick on this and axis titles, primary vertical axis title as vertical rotated. Enter this name of the axis as stress. The unit is MPa. The thickness of this graph of the line can be changed from the shape outline. Enter the thickness for this for the better visibility purpose. This is how we can conduct the design of experiment or design optimization in ANSYS. This example is a very simple example. This can be, or this methodology can be leveraged to any of the complex problems. You can see the mesh, pick on the graph, for animation. Thank you for watching this video. If you like this video, please click on the like button just below this video. To get notified by my new uploads, please click on the subscribe button just below this video. Don't forget to share with your friends, colleagues, teachers, and subordinates.